lungs are not anatomically attached to the thoracic wall. Rather, there is a what? A pleural cavity with pleural fluids that enables the lungs to what? To perform inflation and deflection without any mechanical friction. And then, another thing also you must take note about this anatomy of the respiratory system is that by having this pleural space, we have pleural membrane. Of course, we know membranes are thin, pliable layers of epithelial tissue that are found covering what? Surfaces of what? Organs. Surfaces of organs. And therefore, having the lung as an organ, we have the pleural membrane covering it. And this pleural membrane, the pleural membrane are of two types. The pleural membrane covering the lungs are of two types. What are these pleural membrane? We have the visceral pleural membrane and we have the parental. The parental pleural membrane and the visceral pleural membrane. Now look at where they are found. Already now we know that on the left lung we have two departments, two lobes. As you can see, this is one lobe, this is another lobe. Are you seeing this now? Then on the right lungs, we have three lobes. 1, 2, 3. So on the surface, because membranes, like we said, they are what? They are covering layers, right? Now on this lobe of the lungs, we have the pleural membrane, which we call the viscera. So the visceral membrane is the one covering the lobe surface, tightly covering the lobe surface of the lungs, the right and the left lungs. Are you seeing this now? Then what about the parental membrane? The parental membrane now is the one covering the surface of the thoracic cavity. How will I explain this for you now? It's just like, okay, it's just like this is a thoracic wall. Are you following now? Then this is your lung. Now, the lung, this lung is not attached to the wall. I said there is a space in between. There is a space like this in between, which we call the pleural cavity. And in between this pleural cavity, the lungs has the ability to inflate and deflate. So as you are breathing in and out, this is what is happening to the lungs. The lungs are inflating and deflating without what? Touching the thoracic wall. Are you getting this now? So now, in this pleural cavity, which is this space in between these two, there is a membrane, which we call the pleural membrane. This pleural membrane, they are of two types. I said we have the visceral and we have the parental. Now, the visceral membrane is a membrane covering the surface of the lung. That means the lobe section of the lungs. On the right, on the left, the two lobes. On the right, the three lobes. Covering it, tightly covering it. While on the surface of the thoracic wall, the membrane covering it is what we refer to as the what? Parental membrane. And anatomically, there is one thing you must know. Okay, look at it here. Let me decorate so that you will be able to see. This is already the surface of the thoracic cavity. The thoracic wall on the rib cage. The surface of the thoracic rib cage, the membrane covering it is parental. Are you getting it now? While the surface of the lung, now the surface of this lung, the surface of this lung, and the surface of this lung, no, this one lobe, this second lobe, 1, 2, 3 lobe, they are surfaces. The membrane covering it is what? Viscera. So these are the two membranes. They are all pleural membrane, visceral and parental. And now, in between, get the anatomy now. In between the visceral membrane and parental membrane, there is a space. Are you getting this now? There is a space. This space is what we call the pleural cavity. That is filled with fluids that enables inflation and deflation of the lungs not to have a mechanical friction. Are you getting it now? Not to have mechanical friction as you are breathing in and breathing out. And therefore, the two membranes Why am I showing you this? The two membranes are not working independently. What I mean by that is that their function anatomically is not separate. In other words, if the parental membrane moves, it also moves, the visceral membrane of the lungs also moves along with it. So they are moving in the same direction. That is how come when you breathe in and breathe out, you see that your rib cage moves in the same direction, right? As you breathe in, your rib cage moves. As you breathe out, it moves. They are moving in the same direction. So that's to tell you that the lungs, deflation and inflation we are talking about by breathing process is also coordinating with the two membranes are coordinating together. Now, what will happen if somebody is stabbed? Let's say somebody is stabbed with a knife. If you carry a knife now and stab this person on the chest, let's say you create a knife, a passage here now, you stab somebody here. What have you done to this membrane, these two membranes? If you put a knife here and stab somebody on the thorax, what you have created is that now you have decreased the pressure of air. And in that way, like I've told you, the parental membrane and the visceral membrane, they move hand in hand. Both breathing in and breathing out, inspiration and expiration. So by creating this space here now, you find out that now, if the parental membrane is moving now, it cannot move with what? If the visceral membrane is moving, it cannot move with the parental membrane. And that will create a loophole. Are you following now? Which we can refer to as pneumothorax. And in that condition, if it is not attended to, it can lead to the collapse of the lungs. And when the lungs collapse, automatically what will happen to oxygen intake and exchange? That will lead to what? Death. That will lead to death. Because anything that will lead to these lungs to collapse in function, it means the exchange will not be able to what? To be carried out again. And when that is not carried out again, the person is dead. The person is dead. So these two membranes, take notes, they work hand in terms of what? Inhalation and exhalation, which is what? Inspiration of oxygen and what? Expiration of what? Carbon dioxide. Okay, now that we have seen how the structure looks like in its form, now let's look at the journey of oxygen, really, from the bronchi, because already we said this is the bronchi. The left bronchi, the right bronchi is the bronchi that enters into the lung. Now, let's say this is a bronchi. Are you following? Now, we're looking at the journey of oxygen in the bronchi. This is bronchi now. Let me bring it up. Now, in this bronchi, as you can see, the bronchi enters into the lung. As it enters into the lung, of course, I'm taking the left bronchi. The left bronchi divides into two lobes, as you can see. It divides into two lobes. And on division of these two lobes, this is what it forms. It forms alveoluses. It forms alveoluses. And this alveoluses now leads to a structure like this. Then the same way too, on this, it also forms alveoluses. It forms like this. Okay, now what you are seeing here is the journey of the bronchi, how oxygen goes from the bronchi into the alveoli. I repeat again, what I'm showing to you now is the journey of bronchi to alveoli for gaseous exchange. I repeat again, the journey of bronchi to alveoli for gaseous exchange. Already we know that alveoli is the final bus stop of oxygen. Are you following now? Alveoli is the final what? Bus stop of oxygen. And therefore, this journey through the bronchi, as it goes, as you are seeing it goes into the lung, going in this direction, when it bifurcates and goes into these lobes of the lungs, this is the journey. It's being stored in the what? Alveoli. Okay? Let me show that in arrows so that you see this is oxygen going in. As oxygen is going in, of course, two lobes in the left lung, it goes in into this, it goes in into this, and then goes straight to where? Into the alveoli, which is the final bus stop of oxygen. It goes to the alveoli waiting for what? External respiration, which we said is the respiration or the exchange of gases between the what? The lungs and the blood. Are you following now? The lungs and the blood. And therefore now that we have this is where pulmonary circulation now takes place in respiratory system. Now, for you to understand pulmonary circulation, first you must know how the heart works. Are you getting this now? Which I'm going to show to you briefly so that you see the connection. You will now see the connection of the cardiovascular system with this respiratory system. To tell you how God is a beautiful master designer in such a way that this works perfectly in harmony without any destruction. Of course, you know, here in these parts, we have a structure. At the left side of the heart, at the left side of this, in between these lungs, we have the heart. And the heart has a relationship with the lungs. The heart is cardiovascular, the lungs is respiratory. And therefore, what is this relationship? By talking about the external respiration we talk about. The external respiration is all about the pulmonary circulation. Of course, this is, permit me to show the heart in this way. This is the human heart. The human heart has 4 chambers. Are you following now? There are 4 chambers in the human heart. Of course, remember we always say our left, our right. Take note of that. These 4 chambers of the heart, we have the vision here. Atrium, ventricle. So right atrium, right ventricle. Are you following? Then left atrium, left ventricle. Of course, blood going into this right part of the heart, it enters like this. Every blood that is going into those right part, it enters through what we call the inferior vena cava. And then the blood coming from the up into this right part, it enters into this right atrium through what we call the superior vena cava. So these are the 2 tubes that carry blood into the right part of the heart. Of course, you must take note, like I've treated in my previous videos. If you have to go and check about the blood flow system that I treated in my videos, I said that blood do not move from right to left in the heart. Blood goes into the right part of the heart, leaves the right part of the heart without going to the left. Where does it leave to? It leaves the right part of the heart and goes to the lungs. It goes to the lungs for what? External respiration, which we invariably call the pulmonary circulation. Are you following now? Which we call what? The pulmonary circulation. And how does that happen? Of course, every blood going into the right part of the heart is deoxygenated, which means it is more of what? Carbon dioxide, CO2. Every blood that is deoxygenated is more of CO2 and low of oxygen. While blood that is oxygenated is more of oxygen and low of what? CO2. Are you getting this now? I repeat again, deoxygenated blood is high more in carbon dioxide and low in oxygen, while oxygenated blood is more of oxygen and low in what? Carbon dioxide.